we'll talk about addressing safety issues through prevention through design. Why is it moving?
It is not changing, Professor Krishna.
It's not there. That's what I'm seeing.
Perhaps you have clicked some item by mistake. It happens earlier also. So again you share.
Yes.
Something wrong.
Now it is changing, sir.
It changed, but that change is only one slide change.
Yes.
But during the trial session, it works so nicely.
If something happened, I said today.
Yes, you have shared.
Okay.
You have shared. Now you move to the third slide. Yes.
Okay.
Yes.
Okay.
Yes, sir.
Okay, gentlemen, I would like to take you through the banyan tree. All of you must have seen this banyan tree. You will not see anywhere, any place in the world without banyan tree. But why I'm taking to banyan tree is the separate purpose. You know very well, banyan trees will have aerial roots. Whenever it requires, the banyan tree will generate aerial roots, which will work as the prop roots. They work as the prop roots. If you go to a state in Andhra Pradesh, a district in Andhra Pradesh, you will see a banyan tree spread around 5 acres. How is it happening? It is happening. Banyan tree has got a design by itself to prevent from the hazards by dynamic aerial roots. Dynamically, the tree will create preventions for the hazards which it is going to face. How? It happens. If banyan tree is like this, it has got roots, the branches coming out. As the branch comes out, it is like a cantilever load. Then it will put a aerial root. It will become simply supported. Then it spreads its branch. It continues. As it goes, again it will put one aerial root. It continues. So banyan tree doesn't die. It lives thousands of years. Banyan tree helps us to think the hazards which we have created by different means. Why can't we address? If not like the banyan tree from the design stage. This banyan tree is the only tree, if I know, has got this phenomena. But there are pioneers like Jay Tata who created Jamshedpur. It has come after his death, but he has written to his son, Dorabji, that the city should look like this. We should have green trees, wide roads. It should have the temples, churches, masjids. It should have playgrounds, all these things. Yet the conceptual stage of the steel plant, which has come in Jamshedpur, he has thought of all these things. And finally, Jamshedpur is the only city now in the world owned by private company. And this is one of the best cities in the world, not only in India. It is called Green City. There are many visionaries like Dhirubhai Ambani. When Jamnagar refinery was being constructed, they were thinking to what seismic load it should be designed. People are talking 7.5. See, seismic load, if you want to increase for design for more seismic load, it will cost very high. Then people went to Dhirubhai, who said to the whole world, think big, think fast, think ahead. Ideas are no one's monopoly. This is what Dhirubhai has thought. When the engineers went to Dhirubhai Ambani, who was not an engineer, they have said the problem to him. So he said, what is the maximum earthquake which has come in those areas? For that it should be protected. They said some 7.5. He said, go for 8.5. And in 2001, the Bhuj earthquake came. All the industries around that area were gone, gutted, except only Jamnagar refinery. Thinking from the conception. So prevention through design, or design for safety, or safety through design, or designing out of the hazards, or designing in safety, whatever you call. People call in different words. This is nothing but integration of hazard analysis and risk assessment methods early in the design and engineering. Very early in the design and engineering, you should understand hazards, what are going to come, what is the risk going to come, and you put it in the design stage and take necessary actions so that the risk is always alert level, as low as reasonably practicable. This is throughout the life cycle, not only at the construction stage, not only at the operation stage, not only at the maintenance stage, not only at the decommissioning stage, throughout the stages. The designers should think and they should bring the interventions to the hazards which are going to come at different stages at the design or engineering stage, like Banyan Tree. That is what is prevention through design. It's very easy to tell. Let me tell you, gentlemen, there are three types of disciplinary approach happens in the world. One is the multidisciplinary activities. You have different disciplines like mechanical engineering, electrical engineering, or different electronics engineering. They work in their own domains and for a common goal. They work independently, but it happens common goal is achieved through some integration. This is called multidisciplinary approach. There are many multidisciplinary approaches are there. Different people work in different countries on different issues. Finally, they get together. The COVID is one of that. To get the solutions for COVID, people worked at different countries together, and they got together for the common research program. Second thing is interdisciplinary. The people work together. They cross the boundaries. And they work to the final solution. So you'll have all cross-discipline teams which you make in the industries for solving a problem. Any problem in the industries which you get, you constitute a interdisciplinary team, and they get the solutions. All work together for the common goal. They cross the boundaries. They take collective responsibility. So each can intervene in other areas and help That happens very successfully in the industries. There is one more disciplinary approach. This is called transdisciplinary approach. It doesn't have any limits. It doesn't have boundaries. Disciplines work together, cross together, but they cross their boundaries, go out and go to social science, humanities, society, natural science. All these things they intervene. They cross their boundaries. They cross their boundaries to outside radially, go into all the subjects. No boundaries. No boundaries to this. So, gentlemen, the PTD is the transdisciplinary subject. It doesn't have any boundary. It takes care of all the issues at the design stage. What is going to the society? Like LG chemicals in Voltaire, what happened? It went into the society. The chemicals passed into the society. Many things happened. Or Bhopal, anything. So they don't limit to their own areas. They go outside, work for the solution. Own area. No limits to them. This is PTD is the transdisciplinary subject which work beyond the boundaries to improve safety, to bring safety at the design stage. PTD works on the hierarchy of the interventions. The hazards which are coming at different stages, they want to put as far as possible first elimination. Then it is not possible. For the hazard is serious, very serious, they put elimination or substitution otherwise. At the third level, they bring engineering controls. What is engineering control? Engineering control is, if you see Indian Railways, after working for more than 100 years, Indian Railways, we used to have many people dying at the intercrosses, unmanned crossings. Lakhs of people died all these years. But now they brought road under bridges, road under bridges, and they have eliminated all the rail crossings. This is called engineering controls. So engineering controls is the best, is the third best. They have not eliminated, but they have put the engineering interventions. If these are not possible, then finally we'll go to warnings, administration, correction, PPEs. These are the things in PTD people follow. What they look for the elimination, if it is applying PTD in your workplace, it's a huge business case. It is not just like that we are IIT is one who is getting into through their CoE-SEA to help the whole humanity to address the hazards at the design stage. Not for that you need not do. You have a big business case. Every year, 2.3 million people are losing their lives because of the work-related injuries or illness. Every year, around 7,000 people, every day 7,000 people are dying. And there is 171 billion GDP loss, which we can use for many other purposes if we address. And it is shown in the present research in the Australian companies that 37% of the work-related fatalities, serious incidents, are related to design. People not addressed at the design stage. So fatalities which happened, the incidents which happened in copper alpha, union carbide, have closed the facilities, safety issues. Companies lose reputation. Their project schedules will be delayed. Of course, now people are putting some quotes, but knowing this very fully, why is this not happening? Why people are not able to understand it? Because of you. You means engineers. They look for the functional requirements. Train means it has to take people from one end to other end. Passengers, loads. In between, if people come and lose their life, no, it's not my job. It is not functional requirement. How many of you know the driverless cars now really held up because of the hazards they are not able to, safety hazards they are not able to understand, not functional requirements. Designers are looking for only functional requirements. They see, somebody is talking, please mute. Designers are reluctant to put the safety requirement at design stage because it will increase the cost. If the cost increases, the designers will be called ineffective. He feels safety is not my baby. And there is no consequence to the people if it is not put in the design. There is no consequence. I am very happy to tell the Occupational Safety and Health and Working Conditions Code 2020, which has come in India now, going to be implemented very soon, told manufacturers, designers, if the incident happens because of them. I appreciate Indian government. Why designers are not really doing at the design stage? There is one more reason. They don't have knowledge. Mechanical engineers study mechanical engineering. Electrical engineers study electrical engineering. Computer engineering people study computer engineering. There is no inputs by the premier institutes like IITs or MITs to the students on the safety. Safety means understanding the hazards, calculating the risk, putting the intervention. That is how, as I said, the birth of CoE-SEA, Center of Excellence and Safety in Safety Engineering and Analytics, which has come first time in the world to address these things and give these inputs to the students. This I have already explained. Before I take to Ptd model, I should explain you what is safety. To understand that, you should know hazard and risk. What is hazard? Hazard is some potential energy which can harm you. It is the potential energy which can harm you. Like the shark here, it has got potential to harm people. Risk is, what is the probability of the shark coming and eating the person, or the person going to the shark and getting affected? Probability. And if the shark attacks the person, what is the severity? So severity, consequence. Safety itself, safety can be defined, measured by the risk. safety can be assessed by the hazards. To understand the safety, you should understand the hazards, you should understand the risk. Where does these hazards and risks have come? Before 1800, where there was no industrial revolution, we were going on the bullock carts. We did not have any hazards. We were very happy, though it may take long time, though we are not very, very comfortable, but there were no hazards created by us. If you want to overload, bullock will not agree. It will sit down. But you want to go faster, you want to have more comfort, then you invented first industrial revolution, mechanization, mechanical power, everything has come. You started driving on the cars. You got some comforts up to here. Then you want further comfort. By 1900s, you invented electrical power. So mass production, the comforts in the houses, ACs, all those things have come. Then your comforts have gone up to here. Then there came third industrial revolution in 1960s, where digitalization has come. The PCs, the electronics, and you started putting everything in computer data. Then automation, everything has come. Then the fourth industrial revolution, where you got digitalization. You started using the data for your own comfort. That is digitalization. Or the smart automation, smart factories. But all these things, they have given comforts differently. But they have also given you the hazards, which you have not addressed. You have addressed your comfort by functional requirements. That is how Ptd, that is how hazards have come. Hazards have not come off it their own. It is because of your trusted to have more comforts. Now you are thinking, because once they started killing 2.3 millions of people in the industries, lakhs and lakhs of people on the roads. Now you wanted to address. It is not very new. Ptd as people have applied some years back. But now NIOSH is very, very worried. They think that education to the designers have to be given at the industry level, in the education level. All the students should be given on the safety engineering principles, explained on the safety engineering, that means hazards, risk, intervention at the engineering stage, so that when they work in any field, they will apply it. So this is what NIOSH has defined now. Occupational safety and health needs, they should be addressed at the design. Redesign means, redesign or retrofit means, suppose if you have already your plant, many plants are already working. We cannot say you cannot do Ptd. No. If you are at the construction stage, or if you are at the operation stage, or if you are at any life cycle, think of the hazards there. Think of the risks, put the interventions using design principles. That is called redesign. So if you have a factory already, don't think that Ptd is not my baby. Still you can apply. That is why the Ptd, prevention through design, prevention through redesign, we have coined. It should be applied at the construction, manufacture, maintenance. In your maintenance, Ptd is not applied now. Apply it with prevention through redesign, with the same principles, understanding the hazards, calculating the risk, and putting the interventions. So it is very important for the sustainability. It works on the three principles: sustainability, collaboration, and innovation. Innovation is very, very important. If you see Ptd, if you want to apply in the design stage, you require innovative approach. Now let me take you to the Ptd model. IIT has contributed a lot in developing this model. Of course, there were fundamental models developed. We have developed that existing models with the whole experience. The IIT is working for last 25 years in the safety field. What does it say? You have in the life cycle, in the total life cycle of the industries, equipments, you have business concept. I should bring steel industry in India. I should make a mobile which a common man should be able to use. Business concept. Not a single drop of blood should fall on the factory wherever I put my factories. Tata's business concept. So at the business concept itself, you give your policies, your vision. There itself, you can put many requirements. Then it comes to design stage. Convert those conceptual things into on the drawing board, on the executable way. Next, it is built. You have to manufacture and build construction. Then next, you have to operate and maintain. Finally, you have to decommission. For any of the things, this is what it happens. We have very bad business concept. Somebody will have very bad designs. All these things may happen. But without design, you cannot build anything. All these things may happen. But design, you cannot build. Your design more efficient and effective towards safety. You have to shift safety upstream, not to the downstream. Designers, if they don't know what is safety, they will think, okay, it will be addressed at the construction stage, or it will be addressed at the manufacturing stage. Construction people say, okay, let me somehow complete my job. Let me push all the safety issues to operation. That is called pushing to downstream. This is not safety. Safety is pushing towards the upstream. Understand the hazards, calculate the risk, understand the hazards, calculate the risk and interventions, put all those interventions at the design stage. If you do this, the cost of intervention will be very less. Very less. On the drawing board, if you put the intervention, what will be the cost? If you want to do it at the operations stage, the cost will be very high. Similarly, ease of intervention. If you want to put some intervention, it's very easy to put at the design stage. It is very easy. Ease of intervention will be very, very less as you go toward the downstream. This is what is redesign. If you have found something in the operation, some hazard, without properly calculating the risk, without properly understanding the intervention, if you start doing it, probably that will result into much more hazards or much more risk. So you have to go systematically. You should understand the hazards, risks, what amount is the risk, and how to properly design it and how to properly execute it. That is called prevention through redesign or prevention through retrofit. So for this, what is required? You should have knowledge about the hazards. You should be able to assess the hazards of all the things which you are designing here. And the design board, you should be able to assess the hazards. What is going to come in the operation? People with the low skills will be operating. Hence, I should put a system in such a way, even with the low skilled people will be operating at the design stage. In the construction stage, probably the people may not be able to understand the scaffolds, understand the powered access systems. I should put here itself, you should use the powered access system for the lifting. You should use the proper scaffold. I should put here itself at the design stage. I should give the specification at the design stage. It will happen to understand the hazards, to understand the risk, to understand the intervention. It can be done using the safety triangle. Or and this designers will not be able to do every time this whole exercise. It may be difficult. They may understand. So there should be given a database of various hazards, various risks for each activity. They should have checklists. In addition to the knowledge which they have, if you give database and checklist, they'll be able to put for every activity, for every hazards, for every activity of the construction, operation, commissioning, decommissioning. If you give the checklist and database, probably designers will be able to decide the interventions. Those interventions should go to, if you are doing this at the operation stage, you should go to operations. If you are doing at the building stage, you should go to building. If you do at the business concept, you should go to business concept. What am I telling? If you have hazard of A at the building stage, construction stage, B at the operation stage, C at the commissioning stage, which are very high. At the design stage, you should understand, you should bring it to small a, which is acceptable, small b, which is acceptable, small c, which is acceptable. At the design stage, you should bring it to a plus b plus c. The combination will be equivalent to alarm level. From capital A plus B plus C, which are very, very high, cannot be accepted, you should bring it to small a plus B plus C by using the understanding the hazards, calculating the risk, using the database, checklist, all these things. This is what is prevention through design. I'll take another 2 minutes. Not only that, I want to conclude by telling you one thing. Prevention through design means you should look at the constructability, operability, maintainability, decommissionability. In very, very simple terms. You should look at the cost. You should look at the duration. You should not do something, design something which cannot be borne by the people. By the name of PTD, you cannot tell the sky has to come to the earth. Should look at the quality and finally safety also. All things should be seen in the context of constructability, operability, and maintainability. Gentlemen, please understand, there's a big ethical reasons. The National Society of Professional Engineers, to which we all belong, they say it is your ethical responsibility that engineers shall hold paramount the safety, health, and environment welfare of the public in the performance of their professional duties, whether your organization accept or not, your society accept or not. You have taken degree from the institute and you have become an engineer. It is your ethical duty. What is ethical? I say, I will not do any corruption. That could be ethical. I'll make my daughters a big engineers. That is ethical. At any cost, you will not compromise it. That is ethical. And the American Society of Chemical Engineers, they have told most engineers are employed by private companies. You'll get good wages, you'll get good benefits. The company has to earn profits. Shareholders, engineers must provide service. That is there. But they are also responsible, equally responsible, minimizing the losses by providing safe and secure environment. And overall, the most important ethical duty is you have to save yourself first. You have got the responsibility to yourself, fellow workers, family, community, and engineering profession by putting real safety at the design stage. This is your ethical responsibility. Thank you, gentlemen. With this, I'll close my presentation.
Yeah. Thank you, sir. Thank you for this nice presentation. Nice talk on prevention through design and redesign. Now we have some questions in the chat box. I'll take one by one. So the first question is, have we analyzed the cost versus risk while implementing PTD?
There are many people, when they implement PTD, that will be definitely less than meeting the accidents and seeing the consequences. Anything you do by design, it is by preparing in advance. At any stage, instead of waiting for the accident and getting into the consequences, which cannot be borne by the society, family, organization. If you design, properly understand the hazards, understand the risk, putting the interventions, plan. Once you understand, you need not do everything at one place. You have to plan. The most serious things you do first. Rest, the moment you understand the hazards and the risk, you can manage by some other means by certain time. But these costs will give huge return of investment. Okay.
Yes, sir. Thank you, sir. So the next question is, sir, behavior of the people also be taken into consideration at design stage. That is, who is handling the job. Can you throw some light on this one?
It's Ashish, it's whoever had asked.
Yes, sir.
Very good. Whoever had asked, it's a very good question.
Okay, yes, sir.
People
Ramakrishna Rao.
People call cultural PTD. The cultures, why the cultures are coming like that? Behaviors come like that. The unsafe way of behaving will come. You have not understood the hazards. You have not understood the risk. You have left the people to work like that. Nobody want to die. Nobody want to get injured. Please understand. Even the baby don't want to injured. Very careful. But you have created such a condition that people start behaving unsafely. The people who go to metro station, they behave very dignifiedly. They don't do any mistake. Why? The moment they come out of the metro station, they behave differently. Because metro station is made in such a way, hazard-free. People will behave like that. So at the design stage, when you put all these interventions, the behaviorals will change. Also, some more, there are a lot of research is being done on the behaviors that learnings also could be implemented in the design stage. Finally, it is the conditions have to be changed. Then only behaviorals will change. The Henrich triangle, all those things people are challenging. We the academicians challenge all those things. We give earlier days people used to say the behavior should be given more important, behavioral based safety to be given more important. Now the researches with huge evidence has come. At least 70 to 80% of the safety could be improved by putting real engineering controls. Yeah, Ashish.
Yes, sir. Thank you. So our next question is, in the startup ecosystem, companies follow a lean management system by deployment of like contractual suppliers, manpowers, and resources. In such a culture, how can the same concern of safety be passed on to the suppliers?
Very interesting and practical question. When I was in Tata Steel, when we are expanding to 5 million tons, 50,000 contract workers used to be there. We thought it's very unmanageable, very difficult. Then we called DuPont to help us. DuPont said, hey, this is your strength. It's very easy to change the behaviors of the contract workers than the middle management, than company employees. Finally, the contractor safety in Tata Steel is better than the employees' safety. Thinking that, but how do you train the contractors? How do you assess the contractors? What requirements you put before the contractors? First, you should know. If you know what is the safety, if you know what standards are to be followed, then you impart that to contractors. They will also follow. So PTD is safe for everybody, whether it is contract worker, company worker. PTD is understanding the hazards. Even the contract workers is the hazard. Those interventions also you can put it in the design stage. Yeah.
Yes, sir. Thank you, sir. Thank you for nicely explaining the answers. So now I would request Professor Maiti to formally provide vote of thanks to our expert speaker.
Okay.
I think he is engaged in that.
Okay. I am the one of the organizers. It is my duty to take care of the situations. Thank you all the people for hearing to this. And again, next week we'll have a talk from the.
Ashish, the sir is there actually.
Yeah, sir is there, but he is mute.
Actually, your sound is not audible. That's why sir has not got the sound.
Now, okay. Now, sir is
now
there.
your sound is audible. Yes. Yes,
Hello?
Professor Maiti.
Shobhik, I am audible?
Yes, sir, audible.
Sir, we request you
Okay.
to provide vote of
Go
thanks
ahead.
to our expert speaker.
Okay, so Professor Krishna, thank you so much. So what I can tell about your presentation, so I do not want to tell anything because the area, the PTD, that the way you explained, and starting from that banyan tree to finally engineering ethics in between the life cycle, system life cycle, then finally linking with the entropy risk. And those things are extremely useful and beneficial for the people who are working in the safety domain. And I hope that all the participants they have got the basic philosophical understanding of prevention through design and why we basically focus on that early design at the early stage of design you identify hazards and put the interventions. So these things you have very nicely explained. And obviously, that within this short span of time, it is not possible to go into the nitty-gritty of the prevention through design concept. So we are extremely thankful to you, Professor Krishna. And definitely another one thing I want to tell, that in some lecture, maybe in coming weeks, not immediately, but we will go for a elaborate we'll take it forward from this concept to some other application side also. But most of the lectures, wherever the design related issues were discussed, I am sure that now with those applications what you have seen earlier, with today's lecture, you will be able to correlate. So thank you, Professor Krishna, for this, and I also thank all the participants for joining the this presentation. And we are basically also a little bit, actually we are sorry that we could not, that because of technical reasons, that connection problem, Mr. Chatterjee could not present today. Obviously, Mr. Chatterjee will present in some other day. And we are extremely thankful to you. Obviously, we are thankful to Mom and Sween and Sobik, Ashish and other that our team members, and also the research scholars who have joined today. Also our PTD course participants who have joined today. So thank you very much. Thank you, Professor Krishna, for your excellent speech and real insight into the PTD.
Yeah, thank you very much.